Johnson,
Hello, my name is Dr. Delaney.
and our project is a Cubesat that will detect space junk.
Problem statement. Today there are 75 to 100K pieces of space junk that are untraceable by ground-based systems. This junk is created both unintentionally by debris and intentionally by ASAT tests. This problem will continue to grow over time unless mitigated. Everyone on Earth is affected by this problem as untracked space junk is a danger to all satellites as well as humans in space. NASA and other government space agencies have highlighted the danger of space junk and how they are unable to detect or prevent it.
Our product proposal is a plan to create a low-cost Cubesat that would be able to detect space junk at sizes that are currently untraceable from the ground. This school year, we would complete basic design and concepts for the satellite. The main systems would include LiDAR for detection, communications, navigation with 18 megachips of the brains running C++, and all running off an integrated power system. The satellite would be designed to last around 6 months. It would operate in low Earth orbit, launched on a commercial launcher piggybacked on the main payload.
For our project, we have divided into different subsystems. For me, I'll be working on the power subsystem. Command and control subsystem will be worked by Jim Johnson and Riley Martin. The LiDAR subsystem will be worked on by George Weary. The communication subsystem will be worked on by Kyrus Jenkins. And the navigation subsystem will be worked on by Caleb Brandt. This is a picture showing power subsystem in greater detail, which displays the solar system taking from it and putting power into the inputs portion of the power system, the batteries inputting and outtaking power from the storage system, and the storage system giving power to the command and control subsystem.
So far this semester, on my work that I've completed on the command and control subsystem, includes the computerized schematic and circuit board design finalized, which was made in Eagle, created and successfully tested a basic I/O verification circuit using an Arduino Uno. I've designed it so it will run off an ATmega 2560 chip along with a custom PCB which is the general circuit based around the Arduino Mega 2560.
This semester I've been working on a power system with the goal of designing a power system concept and a rudimentary schematic be finalized once other components are finalized and total power requirements are fixed. I was also instructed to test basic solar panel and charging circuit. This test initially failed due to low quality solar panel and faulty batteries. We're currently working on a new test for this. The first experiment which I worked on for the power subsystem included creating a test circuit using solar panels and 9-volt batteries in order to verify the general power subsystem concept. The test was unsuccessful and determined to be caused by inadequate and unpowered solar system panels.
The experiment number 2, which was a circuit design checkout, I designed, created, and successfully tested a rudimentary circuit following the processes planned for the main circuit design and testing. We used an Arduino Uno to test a basic code, and it was successful.
The third experiment is also for the power subsystem, which is currently being tested, which requires us to create a new test circuit, change the solar panel battery, and charging system. This is a picture of the first experiment in greater detail. Here are more pictures. Pause if you want to look further.
Here's some of the code that we used for my basic I/O design using Arduino Uno.
Here's the Gantt chart showing current tasks that we completed and future tasks that we plan on completing.
So for this semester, satellite design and construction, even for tiny CubeSats, could take many years. So we'll only be completing basics, research, and design for our subsystems. For my subsystem, command and control, it is substantially complete with the schematic and PCB design tested virtually and ready to be printed to test.
For the power subsystem, we're supposed to design a concept substantially, which is complete.
So for future innovations, the size could be reduced through miniaturization and general size reductions, which could allow swarms of these things to be launched, which could monitor whole portions of space using a net until a pre-programmed orbital decay. It could also increase sensitivity and capability of sensors such as the LiDAR, to improve the detection and enable high-fidelity tracking. You could also use new sensors such as magnetivity. Capturing or even destroying detected space junk using tools such as mini lasers, capture and azimuthal orbital decay, electromagnets, and even more.
For upper competition, during the semester we worked on a student design competition to monitor the environment based around an Arduino Cortina H7. Our design was for a semi-autonomous water quality survey plane that would decrease the cost of collecting data about the health and quality of bodies of water. We practiced circuit board and schematic design as well as command and control system integration. We submitted this it's on in mid-November, currently waiting results.